So today we're gonna do a practice session for chapter 6, which is hypothesis test. Okay, so we're gonna do 5 questions here for different sections. Okay. So here in this document, at least almost all the equations available for chapter 6. Okay, so you can see here. Here are different situations. For example, 6.1 section. We talk about large sample test for population mean, okay, and we need to calculate the z-value, the z-score, okay, and here is the setup of H0, okay, so mu less or equal to mu 0, large or equal to, and how we find out the p-value based on the setup of H0 and H1, okay. Next one is 6.4, a small sample test for population mean. Okay, so I put these two together because these are for population mean, both. Okay, and one is large sample and one is small sample. Okay, for small sample, we need to calculate the t-value, as you can see here. Okay, so compare the z-value and the t-value. And for t-value, we have degree of freedom, which is equal to -1. And also, you can see the condition for small sample test is it must be normal. Okay. And then we have test for population proportion. Similarly, here show the condition setup of H0 and H1, the null hypothesis, and the z-value equation for the z-score. Okay. And 6.5 is a large sample test for difference between two means. Okay, again, the equation, which is z-value, okay. And 6.7 is small sample test for difference between two means. Okay, so I put large sample and small sample tests for difference between two means together, so you can compare that. Okay, and condition for small sample, must be normal. And also within here, 6.7, we have two situations. One is for unequal variance. We have equations for here. And another one is for equal variance, which is a special situation. So two set of equations. Okay. All right. And then we have tests for difference between two proportions. Okay. The condition, the setup of H0, the parameters, and equations for the z-score. Okay, and then we have 6.8 pair data. Okay, conditions, setup of H0, and calculations for t-value for small sample and z-value for large sample. Okay, so I'll upload to this set of equations to Lorima this morning. Okay, so we're gonna use it to resolve the questions today. Okay, so the first question is page 424, question number 6. Okay, which is here. So the ACL, which is anterior cruciate ligament, so runs diagonally in the middle of the knee. Okay, so ACL in the knee. So one of the articles, okay, so report the result for 85 young athletes who suffered ACL injuries. Okay, so out of these 85 injuries, 51 were to the left knee and 34 to the right knee. Okay, so can you conclude that more than half of ACL injuries are to the left knee? Okay, so first of all, let's look at the last sentence. So can you conclude that? So based on that, we know this is chapter 6 questions, hypothesis test. And then more than half, this is actually a question about proportions. Okay, so more than half of ACL injuries are to the left knee. So we know this is a hypothesis test for proportions. Okay, so which is go back to the equation sheet here. This is test for population proportions here, section 6.3. And we need to calculate the z-score here, right? The z-score. So this is the equation. Sorry, I cannot mark here, but here is the equation for z value. Okay. All right. So based on the information from the question, okay, so we know this is a test for proportion, and this is belong to the equation in section 6.3. And the equation for that, I just write it down here, is this is the sample proportion minus P0. Okay. P0, 1 minus P0, sample size n. Okay. All right. So the question tells us 51 on the left knee. Okay. And sample size is 85. And the sample proportion is 51 over 85. Okay, which is 0.6. Okay, so let's set up H0 and H1, H0 and H1. Okay, so remember, we mentioned this many times. Whatever the question is asking will be H1. And also the equality line always go to H0. Okay, so based on these two rows, let's look at the last sentence. Can you conclude that more than half of ACL injuries to the left knee? So each one will be the population proportion larger than 0.5, so more than half. Okay. So the H0 will be the opposite. So H0 will be p-value, the population proportion, less or equal to 0.5. Okay. So this is the null hypothesis and the alternative hypothesis H1. Okay. So then we calculate the z-score based on that. Okay. So sample proportion here is 0.6. Okay, 0.6. P0 actually is this value. This value will be the P0, under no hypothesis. So P0 will be 0.5. Okay, sample size will be 85. Okay, so based on this information, we calculate the z value is 1.84. 1.84. Okay, so then let's go find the p-value. The p-value. All right. So based on the p-value, we need to look at the z-score, right? So H1 is set up as p larger than p0. So the p-value will be the area to the right of z. Okay. Larger than to the right of z. Okay. The z table is here. Okay. All right. So 1.84. 1.8 is the value, right? Z table 1.84, 0.9671. Okay, so because the areas in the Z table is to the left, okay, so we should use 1 minus 0.9671 for Z value of 1.84. Okay. So that's 0.0329. Okay, so we need to compare that with alpha. Okay, if the question didn't tell us that alpha, so we assume alpha equal to 0.05. So p-value indeed less than 0.05. So we can conclude H1 is true. Okay, H1 is true means more than half of the ACL injuries are to the left knee. Okay, so that's the first question. Next question is page 229, question number 6. 229. Question number 6. Okay. So here, question number 6, a new process for producing a type of novolec resin. Okay. So it's supposed to have a mean cycle time of 3.5 hours per batch. Okay. And we have 6 batches produced. And the cycle time in hours are shown here. Okay, 3.45, 3.47, and so on. So can you conclude that the mean cycle time is greater than 3.5 hours? Okay, again, look at the last sentence. Can you conclude? We know this chapter 6, then it's talking about mean value, mean cycle time. So this is test for mean value. Then go to the equation set for population mean. We have either large sample or small sample. Okay, so for large sample we calculate the z value. For small sample we calculate the t score. Okay, so we only have 6 sample here, so it should be small sample test for population mean, the second one in section 6.4. You can see here. Okay, so we calculate the t value based on this equation. So let's go back to the question. All right. Okay. The second question, this is small sample. Test for population mean. So this is equations 6.4. So the t-score is this. Okay. The equal freedom equal to n minus 1. So based on the 5, 6, the 6 cycle times, we calculate the mean value. The sample mean value, we just calculate this much. Okay, and we also can calculate the sample standard deviation. Okay, this is the equations we learned from chapter 2. Sample size is 6. Okay, degree of freedom is 6 minus 1 is 5. Okay, and then we set up H0 and H1. Okay, again, whatever the question is asked will be H1. So can you conclude that the mean time greater than 3.5? So H1 will be mu larger than 3.5. Then H0 will be mu less or equal to 3.5. Okay. And then we just plug in the numbers into the t-value. Okay, the t-value sample mean is here. 3.50. Okay, mu 0 is 3.5. Mu 0 is 3.5 here. Okay, the sample standard deviation here, and the sample size is 6. Okay, so we plug in the equations for t value. The t score is 0.19443. Okay. All right. So look at how each one is set up. So each one is set up as mu larger than mu 0, 3.5. Okay. So the p-value will be the area to the right of t. Okay. So p will be the area right of t, 0.1943. Okay. So we're gonna use the t table. Okay. Degree of freedom, remember, is 5. Okay. So the t table is here. All right. So t table is here. Degree of freedom is 5. Okay. The t value is 0.1943, which is less than 0.4. You can see here. For degree of freedom, the p value is 0.265 for p value of 0.4. Okay, and our t value is 0.1943, which is less than 267. Okay, so that tells us the p value will be even larger than 0.4. Okay, so here 0.4, 0.25 is the p value. For students' t distribution, it didn't tell us the exact value. It tells us a range. Okay, so we just compare the t value, our t value, which is 0.1943, and see where it is. So it is less than 0.267. So the p value will be larger than 0.4. Okay. So the p value will be larger than 0.4 based on the table 8.3, t table. Okay. So which is quite large. So larger than alpha of 5%. Okay. So we cannot conclude the mean cycle time is greater than 0.5. So cannot conclude. Okay. So basically cannot conclude each one is true. So which means H0 is plausible. Okay. So that is the second question. Okay, so the next one is page 436, question 10. Okay, 436. It's here. All right, so question 10. So in a certain supermarket, a sample of 60 customers who use self-service checkout average 5.2 minutes of checkout time. So with standard deviation of 3.1 minutes. Another sample, 72 customers who use the cashier average 6.1 minutes. And with standard deviation of 2.8 minutes, 2.8 minutes. Okay. So question asking, can you conclude that the mean checkout time is less for people who use self-service? Okay. So this is talking about the difference between two mean values. One is for self-service, another one is for cashier. Okay, so the sample size is 60 and 72. So sample size is large. Okay, again, go back to the equation this. Okay, this is a difference between two means here. All right, so again, this is a large sample. So large sample test for difference between two means. This is from 6.5 section. Okay, so we need to calculate the z-score. Use this equation here. Okay, if it's a small sample, we use equation from 6.7 section. And here has two situations. Okay, so again, we use the z-score. Okay, so for these questions, large sample difference between two means. So we use equation from 6.5, which is the z-score here. Okay. Okay. All right. So this is theta 0. We could use sample standard deviation to replace sigma. Okay. So in this equation, first off, let's set up H0 and H1. Okay. Let's use 5.2 is the mean checkout for self-service. So let's define it as X. So the mean for X will be 5.2. The sample standard deviation for X is 3.1. And the sample size for X is 60. Okay. For Y, the cashier, the mean is 6.1. Sample standard deviation is 2.8. And sample size is 72. Okay. So can you conclude that the mean checkout time is less for people using self-service? Okay, self-service, which tells us H1 will be the mean value for X, which is self-service, minus the mean value for cashier less than 0. Okay, and 0 is the theta 0 here. Okay, so H1 will be the opposite, mu X minus mu Y larger or equal to 0. Okay, and then we just plug in the number. So for mean value of X, 5.2, mean value of Y, 6.1, mu 0, theta 0 is here, theta 0. Sigma X, we use sample standard deviation 3.1. Sample size NX is 60. Sigma Y, we use SY 2.8, and NY is equal to 72. Okay, so we calculate z-score, which is minus 1.74. Minus 1.74. Okay, so because the alternative hypothesis H1 is in the form of less than 0. Okay, for less than 0, so the p-value will be the left of z. Everywhere to the left of z value of minus 1.74. Okay, so minus 1.74, we use the z table, which is here. Okay, so minus 1.74, the z value here 1.7, 1.74, okay, is 2.409, 2.0409 here. Okay, sorry, I cannot mark it up. No, here, okay, 2.0409. So the p-value is 2.0409, so less than alpha of 5%. Okay, so we can conclude H1 is true. Can conclude. You just repeat what the question is asked. So we can conclude that the mean checkout time is less for people who use self-service. Okay, basically H1 is true. Okay. All right, so we have another part for question number 10. So can you conclude that if everyone use the self-service line, that the mean checkout time will decrease? Okay. From the two samples, the people use the average time for self-service line is 5.2 minutes, which is less than use cashier of 6.1 minutes. But can we conclude that if everyone uses the self-service line, the mean checkout time will decrease? Actually, we cannot do that. We should compare the two situations. It could be the people using cashier, they may have more items than the people using self-service. Okay, so if that's the case, then if the people using self-service line, cashier use self-service line, that will not decrease the checkout time. Okay, so this situation may be different. So the people currently using the cashier may have more items to check out than people currently using the self-service line. So if that's the case, we cannot conclude that everyone use the self-service line, then the mean time will be decreased. Okay, so this is possible. So yeah, we cannot conclude that. That is question number 10. The third question. The next one is page 442, question number 12. 442. All right, here, question number 12. So in a study conducted by US Department of Health and Human Services, a sample of 446 boys aged 6 to 11 was weighted, and we found out 87 of them were overweight. Okay. Another sample, 506 girls, 74 of them are overweight. Okay, so we know this is, we have two samples, and we talk about proportions, okay, or overweight, 87 over 546, and 74 over 508. Okay. So can you conclude that the proportion of boys who are overweight differs from the proportion of girls who are overweight? All right, so this is obviously a question about difference between two proportions. So difference between two proportions. Okay, let's look at here. Where is the difference between two proportions? All right, here. So section 6.6, this is text for difference between two proportions. All right, so we need to calculate the z-score based on the sample proportion, px, py, and so on. Okay, so section 6.6. All right. Okay. So section 6.6, so difference between two proportions. Okay, so the equation will be calculate the z-score, px, sample proportion px minus py. And this is called pooled proportion, okay, which is kind of average proportion of x and y. All right. So here the sample proportion px is equal to x over nx. Sample proportion for y is y over ny. And this is called pooled proportion, okay, which is an average of proportion for x and y. Okay, so this is the equation for pooled proportion. All right, and then, okay, so let's define what boys as x. So we have how many? 87 of boys overweight over sample size of boys 546. Okay. And the px is 87 over 546. The girls 75.4, total girls 508. Proportion of girls overweight okay, and then we need to calculate the pooled proportion. Pooled proportion is 87 plus 74 over total. Okay. All right, and then let's set up H1 and H0. Okay, so can you conclude that children who live in, can you conclude that the proportion of boys who are overweight differ from proportion of girls who are overweight? Okay, so basically px not equal to py, or px minus py not equal to 0. Okay, so H0 will be the opposite. Px minus py equal to 0. Okay, and then we calculate the z-score based on this equation. All right, so we got just px, py, and sample proportion is what? Okay, and nx and ny here. Okay, we just plug in number, we calculate the z-score. So the z-score is 0.62. Okay. So because each one is set up as not equal, so we know the p-value will be errors to the two tails plus right and the left of z-value. Okay. So p-value will be sum of two tails for z of 0.62 and minus 0.2. Okay, so all right. Okay, for z value of 0.62, let's look at z table, which is here. All right, z value of 0.62. All right, so that is 0.7324. Okay, so 1 minus 0.7324 is around 0.2676. Okay. So 0.2676. And then we have another one times 2. So the p-score will be, p-value will be 0.5352. So very large, much larger than 0.05. So we cannot conclude. You just copy the last sentence, which basically means H1 is true. So we cannot conclude H1 is true. Okay, so which means H0 is plausible. All right, so that's question number 4. We have one more question. So page 456, question number 9. Four, five, six. Question number 9. Okay, so look at these questions. We're gonna have a table. Okay. All right, so crossover trial is type of experiment used to compare two drugs. Okay. Subject take one drug for a period of time and then switch to another. The responses of the subject are then compared using matched paired method. Okay. So in our experiment to compare two pain reliever, we have 7 subjects. Okay. So 7 subjects took one pain reliever for 2 weeks and then switched to another drug. Okay. And then they rate their pain level from 1 to 10. Okay, with large number representing higher level of pain. And here the table shows the result. So we have 7 people, 7 patients take 2 types of drugs and rating the pain levels, okay, based on the pain level, okay, here. So this is a pair data, okay, like we compare the wear of new tire versus the old tire. So we install new tire and old tire in the same car. So this is a classic example of pair data. Okay, so let's see what question we're gonna equation we're gonna use. So for pair data, section 6.8 is for pair data. For small sample, it must be normal distribution. If sample size is large, we need to calculate z-score. For small sample, we calculate the t-score. So we have 7 patients, so the sample size is small. So we need to use the t value. Okay. So degree of freedom is n minus 1. Okay. All right. So this is pair data, small sample. Is it belong to one of the questions from sections 6.8? Okay, so we need to calculate the t value. This is the difference, the average of difference. This is mu 0. This is SD is the standard deviation of the difference. And this is sample size. Okay. The degree of freedom is equal to n minus 1. Okay, so based on this table, we can easily calculate the difference. So difference will be, for example, 6 minus 5 is 1. 3 minus 1 is 2. 4 minus 5 is minus 1. 5 minus 5 is 0. So the difference will be like 1, 2, minus 1, 0, 2, minus 1, and 2. Okay, so we calculate the mean value for sample difference. Okay. We can also calculate the standard deviation of the d value difference. Sample size n 7. So degree of freedom is 7 minus 1 is 6. Okay, and then we just set up H0 and H1. Okay, again, whatever the question is asked will be H1. Question asked, can you conclude that the mean response differ from the two drugs? So differ means the difference not equal to 0. So the mean value of D not equal to 0. So H0 will be mu D equal to 0. All right. So then we calculate the t value. The t-score mean value of D is mu 0 is equal to 0. Okay. Sample standard deviation is much. Sample size is 7. Okay. So we calculate this t value 1.3693. Okay. Okay. So depending on how H1 is asked, H1 is asked mu 0 not equal to 0. So the p-value will be the sum of the two tails. Sum of two tails for plus minus 1.3693 t-value. Okay, and then we look at the t-table. Remember the degree of freedom is 6. Okay. Here is t-table. For degree of freedom of 6, okay, so our t-value is 1.3693. So 1.3693 is between here, 0.718 and 1.440. So 0.718 is for p-value of 0.25. And 1.44 is for p-value of 0.1. Okay, so the p-value will be between 0.25 and 0.1 times 2. Okay, times 2. So the p-value will be between 0.25 and 0.1 times 2. Okay, so the p is between 0.2 and 0.5. Okay, so very large p-score. So p-value will be larger than alpha of 0.05, so cannot conclude. The last sentence, which basically we cannot conclude H1 is true. Okay, so H0 is plausible. So we cannot conclude that the mean response differs between the two drugs. Okay, so yeah, so that's the 5 questions we